Welcome everybody back to the Bethel College Observatory YouTube channel. My name is Caden MacArthur. I'm a software development major and a senior here at Bethel.
And I'm Miriam Dweeby, and I am a math and potentially software development major here at Bethel. I'm a freshman.
So for our topic this month, we will be talking about Saturn and its moons, and then we will move on to what's up in the sky for October. Saturn has the most moons in our solar system. These moons range from small asteroids that interact and help form Saturn's rings to planet-like moons that scientists believe are capable of holding life on their surfaces. Saturn's moons are likely formed via a co-accretion disk similar to how our solar system was formed, just on a smaller scale. Accretion disks are matter and dust that orbit around a center of mass that usually coalesce through gravitational force into objects like planets and moons. Saturn moons are uniquely named after all the titans of Greek mythology.
Dione is a small moon of 349 miles, approximately 562 kilometers in mean radius, orbiting Saturn every 2.7 days at a distance of 234,000 miles, which is roughly the same distance that our moon orbits Earth. Dione's density is 1.48 times that of liquid water, suggesting that about a third of Dione is made up of a dense core, probably silicate rock, with the remainder of its material being ice. At Dione's average temperature of negative 304 degrees Fahrenheit, ice is very hard and behaves like rock. Very fine ice powder, equivalent to smoke from Saturn's E-ring, constantly bombards Dione. The dust in the E-ring ultimately comes from Enceladus, which has prominent geyser activity. Let's take a look at Saturn's E-ring. Unlike the denser inner rings, which are primarily made up of large particles and chunks of ice and rock, the E-ring is composed of microscopic ice particles so fine that they almost look like smoke. Since Dione orbits within the E-ring, it is continuously bombarded by the fine ice particles that make up the ring. This bombardment contributes to the shiny reflective appearance of Dione's trailing hemisphere, as it continually gets dusted with fresh ice powder. This interaction is a statement to the dynamic nature of Saturn's system. The rings and moons are not isolated from each other. They continuously interact, exchanging material and energy. Moving on to Rhea, which is the second largest moon of Saturn, but with a mean radius of 475 miles. It is less than a third of the radius of Saturn's largest moon, Titan. Named after the Greek goddess or Titan Rhea, who is the daughter of Uranus and Gaia. Rhea is a small, cold, airless body that is very similar to sister moons Dione and Tethys. As with the other two moons, Rhea is tidally locked in phase with its parent. One side always faces towards Saturn as it completes its 4.5 Earth-day orbit around the planet. Rhea, at a distance of 327,500 miles, is farther away from Saturn than Dione and Tethys, and because of this, Rhea does not receive ample tidal variation from Saturn to cause internal heating. This has an important effect. Both Dione and Tethys have more areas of smooth plains than Rhea. Such plains are probably areas where liquid water reached the surface and pondered in depressions such as craters, forming flat surfaces before refreezing and thus erasing existing craters. The lesser internal warmth at Rhea could have resulted in fewer erasures, or there could have been more bombardments on Rhea. Whatever the reason, Rhea is more heavily cratered than Dione and Tethys.
Moving on to Titan. Titan is the largest moon in the Saturn system, and the second largest moon in the solar system. It also has the most unique features of any planet or moon in the solar system. Titan's atmosphere is primarily composed of methane, nitrogen, and hydrogen, and is denser than Earth's atmosphere, making it a bright neighbor to Saturn. On its surface, Titan houses some of the largest lakes in the solar system, which are comprised of certain types of hydrocarbons. Titan is the only other celestial body in the solar system besides Earth that is home to stable bodies of liquid. Next up, we have Tethys. Tethys is one of the most unique-looking moons in the solar system, housing a crater nearly a quarter the size of itself. It only measures about 650 miles across and is composed of mostly water and ice and rock. Being composed of only ice and rock does not allow the planet to be very dense, only having about 1/10 the gravity of Earth. While small, Tethys is still very bright and will be easy to spot through our telescope because of its icy surface. But with that out of the way, Saturn will be our main target of observation during the month of October. Saturn can be seen on clear nights rising in the east around 7:30 p.m. Many moons of Saturn will be visible to viewers with binoculars or small telescopes. Saturn is about the only evening planet visible to the naked eye until about midnight, when we will see Jupiter and Mars rise together around that time. Around this time, Jupiter will be the brightest object in the sky besides the moon, and will slowly rise earlier in the evening as the weeks go on. Similar to Jupiter, Mars will also follow the same trend as Jupiter, rising earlier and earlier in the evening as well. Mars in the night sky can be characterized by its bright red glow in the sky, which is also easily spotted as well. As these objects become more viewable earlier in the day for us, we'll also be looking at these through our telescope in the observatory in the months to come. During our open house event, we'll be observing Saturn to start, and we'll move on to other deep sky objects to image as well. So be sure to be on the lookout for an announcement as to when we will be open. But that's about all we have here for you guys today. Be on the lookout for some announcements regarding our open house event in the near future, and I will see you all next time.
Bye.